Hey YouTube, welcome back. Today we have the second solution to fix this problem or to solve this problem. Problem number 274, H index. Given an array of integers called citations, where citations of I is the number of citation a researcher received for their ith paper. Return the researcher's index according to the definition of H index on Wikipedia. The H index is defined as a maximum value of H such that the given researcher has published at least H papers that have each been cited at least H times. I would say the description of the problem wasn't that good to be honest. It takes time to understand the problem. So if you find yourself struggling to understand how this problem works, what is the point of this problem, just know you're not alone. It takes time to understand the problem because the description is not that good. The problem becomes clear when we look at the first example. So we have this array of citations, and the output is one. It's three. Sorry, is three. The explanation will make it clear for you how this problem is solved and what should we do. So we have this array, we have the output three. This means that the researcher has five papers first. We have the array, we have five papers in total, and each of them had received 3, 0, 6, 1, and 5 citations respectively. Since the researcher has three papers with at least three citations each and the remaining two with no more than three citation each, their H index is three. So because we have three, which is number three, number six, number five, they don't have they have at least three, and the other two they don't have bigger than three. So because of that, we can take three as our H index. In the previous video, I solved this problem in a sorting way which was extremely easy. Today we try to solve this problem in counting. We try to count the each index and find the proper one. But how this work? It will not. We will not put a lot of code. It will be quite simple here. But you just have to be bear with me. I guess in this one I will not go to Miro to try to describe things because I guess it will be easier for you guys to just jump to the code and try to talk about it in the code. So first, I just make some cleanups here. I just because I will use citations.length a lot, so I'll just create a constant in, and after that I'll create another one. I'll call papers, which will equals new array, and it will be array equals from m plus one, and I will fill it with zero. No, fill zero. Okay, so first we initialize a count array. The size and the size papers is in plus one to account for all citations. Counts from 0 to n. This array is used to count how many papers have exactly x citations for each x from 0 to n, for example. After that, I will I'll start to counting papers for each citation number. We will do that by for each loop. So first I will make citations. No, for each. No, for each it will not be like that. For each, okay. And for each citation, I will increment papers of math dot min n or c. We don't know which one, and I will increase it one by one. What's happening here? So first here we count papers for each citation, like we iterate through each citation in the citations array, the for each citations here, for each citation C, we increments the count in the papers array at the index math dot min, and we have n and c. N it's the citation length, and c is the actual index of each element. This ensures that all citations that greater than n, all citations that greater than n are counted together at the index n. It effectively counts how many papers have a certain number of citations with a cap at n citations. Okay. And after that, we try to find the h index. How we will do that? So first, let's just have a variable. I will call it k, and this will be the h index, and it will equals n. And I will do a for loop for let s for equals papers of n, and k should be bigger than s, and s will equals plus. We will add to it whatever we have in papers of k. And yeah, okay, first, and it will be pretty straightforward here. K minus minus, and I will return k, and it's done here. But let's just try to describe this, because I guess this needs a lot of description. So this section, we just try to find the h index. We start from the end of the papers array. Okay, n is a citation the length. So here we start at the end from the citation array, which corresponds to the highest possible h in index n. Okay, we start it from the end, which possible to be the last one. The variable is accumulates the total number of papers. Let me just see here 1 minute to look at something. Okay. Okay, great. So the variable is accumulates the total number of papers counted so far, starting from those with n citations and moving downwards. Okay. The loop decrements k potentially. Okay. We do this one until k is not greater than s, the cumulative sum of papers. This checks from the highest possible h index down whether there are k or more papers with at least k citations. After that, we return h index. Returns k, which is the highest number, such that here there are k papers that can have at least k citations. So again, for that, when we do all of that for each loop, we increase s by k of papers, and we will just try to loop until k is not bigger than s anymore. This was the main idea of the actual loop, and I guess this one will work perfectly fine. Let's see. It did work, and we are beating 89%. The previous one was 38, but this solution is, like, in this section, is quite harder to understand. But I guess by just dividing the solution in three steps. First, we have the papers. After that, we loop through each citation and add increase by one to know how many citations we have. And after that, we just do this for loop to get k, which will be the h index. So yeah, that's it for this video, and hope you like my content. If you like my content, subscribe and hit the notification bell so you never miss a video, and see you in future problem.